Hey everyone, for today's lesson on segments and congruence, we're actually going to split this into 3 separate videos, simply because there are 3 distinct topics that I think each deserve their own emphasis. We're going to start with the ruler postulate, then we will talk about the segment addition postulate, and then last we will talk about congruent segments. To get started, though, let's review a little bit about what we've already learned. Okay, so first, give 2 other names for line AE. So here is line AE. I could call it line AC because lines go on forever. I can name any 2 points on that line. I could call it line EC. And I could just turn any of these around. Line EA, line CA, line CE. Give another name for plane S. So we've named it by a label. So that means that now we're going to have to name it by 3 points that are on the plane. I could use DEF, DBF, EBF. I'll go with DEF. But notice each time I used F because I can't name all 3 from the same line. So plane DEB would not be okay because all 3 points are on one line. I have to have 1 point off of that line. Next, name 3 collinear points. So 3 points on the same line. I have points A, E, and C. So points A, E, and C. Or I could do points D, E, B. D, E, and B. And last, name the intersection of line AC and plane S. So here's plane S. Here's line AC, and it looks like they touch right here at point E, so that is what they have in common. So the intersection is point E. Okay, now in geometry, there are 2 types of rules. There's a rule that cannot be proven and it's accepted without proof. That is called a postulate. Okay? Now, they are considered to be true even though there is no actual formal proof of it, but it is always true in every case. A rule that has a formal proof is called a theorem. In geometry, we will learn a lot of postulates and theorems. Each one just as true as the other. The only difference is there's no real proof for a postulate. There is a proof for a theorem. So our first postulate is called the ruler postulate. It says that the points on a line can be matched 1-to-1 with real numbers. The number that corresponds to a point is called the coordinate of the point. Okay, just like on a ruler, there will be like 1 inch, 2 inches, 3 inches. There's a number line, and every point on that number line has a coordinate. The distance between 2 points, this is still part of the ruler postulate, the distance between 2 points, A and B, can be written like this, A, B, with nothing over the top. In our last lesson, we learned about putting a line, a ray, or a segment. If I put nothing over the top, that also has a meaning, and that meaning means the distance between the 2 points, or the length. So I'll write distance. I'll also write length. That's what it means when there's nothing written over the top. That distance is the absolute value of the difference of the coordinates of A and B. So here is the formula. The distance between points A and B is the absolute value of the difference, so subtracting the 2 coordinates. So if we have a number line, and there are 2 points on the number line, we'll call them A and B, and we'll say that A is at -8 and B is at 12, so 0 is somewhere around here. So the distance between A and B is the absolute value of the difference. So I'm going to subtract these 2. It does not matter the order. -8 minus 12 or 12 minus -8. We're going to end up with the same answer because of this absolute value. Okay, now negative 8 minus 12 is negative 20, so it's the absolute value of negative 20. We need to remember that absolute value means the distance from 0. So how many units away from 0 is negative 20? It is 20 units from 0. So that means the length of segment AB, or the distance between points A and B, is 20 units. When 3 points are collinear, one point is said to be between the other two. Okay, so betweenness, it's an idea that we're all familiar with. It's important in geometry because when we talk about the segment addition postulate in our next video, still in this lesson, it only works when one point is between another two. So here, point B is between A and C. Okay, they're on the same line, point B between them. In this case, and these got cut off a little bit, so there's D, E, and F. Point E is not between D and F. Even though left to right, yeah, it's kind of between them, it's not on the same line, so it is not considered between E and F.